Metals and nonmetals. Introduction. Elements are classified into three categories depending on their physical and chemical properties. These three groups are metals, nonmetals, and metalloids. Metals. Metals are the elements that are hard and shiny in appearance. Some metals used in our daily life are iron, copper, gold, and silver. Metals are good conductors of heat and electricity. Nonmetals. Elements that generally do not shine, neither are too hard nor too soft, are called nonmetals. All the gases fall in the group of nonmetals. Some more examples of nonmetals are sulfur, carbon, and oxygen. Metalloids. Elements which have the properties intermediate between metals and nonmetals are called metalloids. Some examples of metalloids are arsenic, germanium, and silicon. Elements, metals, nonmetals, metalloids. Physical properties of metals. Physical state. Metals are solid under normal conditions of temperature and pressure, with only exception to this is mercury, which is liquid at room temperature. Solid metals are hard in nature, but here also there is exception of sodium and potassium, which are soft metals. These two can be cut with a knife. Color. Most metals are generally silvery gray. An exception to this are gold and copper, which are yellowish in color. Appearance. All metals are shiny. The typical shine of metal is called metallic luster. Metals like gold, copper, platinum, and silver are polished to provide them with a shine. Hardness. Most metals are hard. The exception here is sodium and potassium, which are soft enough to be cut by a knife. Osmium is so hard that it can scratch glass. Tensile strength. Metals have the capacity to withstand high stress. This property is called tensile strength. It is the property that owes the use of iron for the construction of railway tracks. Malleability. Metals can be hammered into very thin sheets. This tendency of metals is called malleability. Because of this property, aluminium and silver foils can be made. They are used for decoration and wrapping purpose. Ductility. Metals can also be stretched into thin wires. This property of metals is called ductility. Example, copper wires. Exceptions are sodium and potassium. Conductivity. Metals are good conductors of heat and electricity. This property, known as conductivity, allows current and heat to pass through them easily. Silver and copper are very good conductors of electricity. Density. Metals generally have high density. Sodium and potassium have exceptionally low density. Sonority. On being hit, metals produce a typical sound, so they are said to be sonorous. This property, known as sonority, is used in making temple bells and many other useful items. Physical properties of nonmetals. Physical state. Nonmetals exist in three different forms: solids, liquids, and gases at normal room temperature. Example, sulfur, phosphorus occur in solid state, while bromine occurs in liquid state. Gases like oxygen and nitrogen occur in the gaseous state. Color. Nonmetals are available in a variety of colors. Appearance. Nonmetals have dull appearance. Graphite and iodine are exceptions as they are shiny and lustrous. Malleability and ductility. Nonmetals can neither be beaten into sheets nor can be drawn into wires. Thus, these are neither malleable nor ductile. These are brittle in nature. Conductivity. Nonmetals do not conduct heat and electricity. These are insulators. The exception here is graphite, which is a good conductor of heat and electricity. Density. Nonmetals are generally soft and have low densities. The exception here is diamond, which is the hardest naturally occurring substance. Tensile strength. Nonmetals can be broken easily. They have low tensile strength. Sound. Nonmetals are non-sonorous. These do not produce sound when hit by an object. Chemical properties of metals and nonmetals. Metals and nonmetals react differently with different substances. Some chemical properties of both of them are given here. Reaction with oxygen. Metals. Metals react with oxygen to form metal oxides, which are basic in nature. Example: sodium plus oxygen at room temperature gives sodium oxide. Magnesium plus oxygen on heating gives magnesium oxide. Copper plus oxygen on prolonged heating gives copper oxide. Gold and oxygen have no reaction. Nonmetals. Nonmetals combine with oxygen to form non-metallic oxides, which are either acidic or neutral in nature. Example: carbon plus limited supply of oxygen gives carbon monoxide neutral. Carbon plus excess oxygen gives carbon dioxide acidic. Hydrogen plus oxygen gives water neutral. Reaction with water. Metals. Different metals react with water under different conditions. Sodium plus cold water gives sodium hydroxide plus hydrogen in a vigorous reaction. Magnesium plus boiling water gives magnesium oxide plus hydrogen. Gold or silver or copper plus water gives no reaction even at high temperature. Nonmetals. Most nonmetals do not react with water. These are, however, reactive in air. It is for this reason that phosphorus, which is highly reactive, is stored in water. However, fluorine, chlorine, and bromine react with water to form acids. Reaction with acids. Metals. Most metals react with dilute acids to form salt and hydrogen gas. Example: sodium plus dilute hydrochloric acid gives sodium chloride and hydrogen in a vigorous reaction. Magnesium plus dilute hydrochloric acid gives magnesium chloride and hydrogen in a rapid reaction. Copper plus dilute hydrochloric acid gives no reaction even at high temperature. Nonmetals. Nonmetals do not displace hydrogen from dilute acids. Some nonmetals, however, react with concentrated acids to form corresponding oxyacid. Example: sulfur plus concentrated nitric acid gives sulfuric acid plus nitrogen dioxide plus water. Reaction with bases. Metals. Metals react with bases to form hydrogen gas. Sodium hydroxide plus zinc gives sodium zincate plus hydrogen. Nonmetals. The reaction of nonmetals with bases is complex. Calcium hydroxide plus chlorine gives bleaching powder and water. Displacement reactions. Metals. More reactive metal replaces the less reactive metal in their aqueous solution. This is called displacement reaction. Example: copper sulfate plus zinc gives zinc sulfate plus copper. Electrochemical series. It is a series in which the elements are arranged according to their reactivity. Potassium is most reactive and gold is least reactive. Nonmetals. Certain more reactive nonmetals displace less reactive nonmetals from their salt solutions. Example: chlorine displaces bromine from bromides and iodine from iodides. Potassium bromide plus chlorine gives potassium chloride plus bromine. Potassium iodide plus chlorine gives potassium chloride plus iodine. Uses of metals and nonmetals. Metals. Iron is used for making bridges, engine parts, iron sheets and bars. Copper is used for making electrical wires and cables. Silver and gold are used for making jewelry, in decorative purposes, and photography. Mercury is used in thermometers and barometers because of its high density and uniform expansion at different temperatures. Aluminium is used in electrical wires and cables. Lead is used in automobile batteries and X-ray machines. Nonmetals. Carbon in the form of diamond is used for making jewelry, cutting and grinding equipment. Graphite is used in making pencils and crucibles. Sulfur is used in the manufacturing of gunpowder and vulcanization of rubber. Phosphorus is used for making things like matchsticks and rat poison. Nitrogen is used in manufacturing of nitric acid and ammonia. Chlorine is used as a bleaching agent and for sterilizing water. Hydrogen is used as a rocket fuel and an oxyhydrogen flame for cutting and welding purposes, as well as a reducing agent.